Alors, nous démarrons avec un très beau sujet qui est en fait celui de l'imagerie satellitaire et de son exploitation. Alors, c'est un domaine qui ne cesse d'exploser et qui explose aujourd'hui pas seulement par le fait que l'on a accès à de nombreuses données, à des photos et à des éléments qui sont captés, qui permettent d'être traités, mais c'est surtout sur les usages et je pense que Jyotsna va nous parler de cela, qui vient de me révéler qu'en fait elle parle un petit peu français parce qu'elle réside à Toulouse, mais qu'en fait tout son job se fait en anglais et donc son intervention se fera en anglais. Mais nous savons que vous êtes, si vous travaillez dans les IT, vous êtes familier avec cette langue. Donc voilà, on va passer 40 minutes avec Jyotsna Budideti, qui donc, est la cofondatrice et CEO de SpaceSense et qui va donc évoquer l'exploitation de l'imagerie spatiale. Merci. Et Jyotsna, c'est à vous, vous avez la parole et écoutez, on vous écoute avec intérêt. Alors, attendez, non, ça va venir. Placez votre micro.
Merci.
Voilà, c'est bon.
Oui? Okay, so thank you very much, Yves, for the introduction. And sorry for my non-speaking of French to begin with.
You don't have to be sorry. No. You do your presentation in English, not a problem. Okay?
All right. So, thank you, everyone, for those who could make it to the event here today, and also for everyone who's watching from their home or their offices in their laptops. So for me today, my job for the next 30 minutes is to talk about how satellite imagery is helping businesses today and what are the changes that are happening in the space industry and how you can use it for your organization, for your use cases. So it's more like an introduction, but feel free to ask more advanced technical questions as well. And so to begin with, today, this is a number, hundreds of petabytes of data. That is the amount of imagery we collect with satellite data in one day. So that's really 1 day worth of data. And to put it in context, it is the same amount of data put together in all of Instagram from the day Instagram began. So that much amount of data we are capturing about the Earth in everywhere, every single day. So that's a huge amount of data, and you can already go, oh my God, that's so much, I can do so much with AI, right? And one of the reasons that today I am making this presentation and it's more relevant today is satellite imagery is more and more accessible today than it has ever been before. It is not new. Satellite imagery has existed for over 30 years now. So what has changed? One is because of the number of satellites that are going there, and the organizations have realized slowly that what they can do with this data, the cost of data access itself is reducing drastically. So just as an example, what I was paying for the same data last year is already 30% cheaper today in 1 year's time. And it's going to be the trend going forward, mainly driven by the number of satellites going up there, the advances in space technology to make it cheaper to send satellites in space, and also competition to be the one, the data provider that everyone uses. So all of them together, it's easier and cheaper to get that information, data today. And the other one is because now we are talking to more and more people, businesses have realized that they need to change their business model. Earlier, if you have to access satellite data, even if you want to only see your single house in that data, you will end up paying for data that is 40 kilometer by 40 kilometer area. You don't need rest of it. You just need maybe a few meters of it, but you end up paying for that. And it is still there, a lot of that, but it is changing really, really quick. So it is becoming more towards pay for what you need. That small bit of data that you need, okay, just pay for that. So that is also changing the availability of this data. The other one is now that we are moving to more data-driven models, data-driven applications, where this data gets used, how this data gets used is changing, which means it is no longer limited to desktop softwares to analyze this data, but you can start using Python that everyone here might know how to use. You can just start working with it today. And just those simple changes have led to talking about how can we make this data more accessible in a more open environment so that you can use it in Python, in Java, or be it in a desktop software that you need to pay tens of thousands to use. So these are the big changes happening. But at the same time, at a more technology data level, there are so many more advances that are also changing. One is, I think when you think about satellite data, the one that comes to your mind first is the images you see of, on the TV or in the internet about very high resolution of data set, the Google Maps kind of data that you see everywhere about any place and how you can use for surveillance. That's definitely, I guess, one of the most used data sets, but that's not the only thing. We also today have radar satellites and hyperspectral data, which completely are very different technology, and what they really push what you can do with that data sets. So if you look at radar data, you wouldn't know precisely, like it doesn't make any sense with our eyes, especially even hyperspectral data, it doesn't make any sense to our eyes. But to algorithms, it helps you do things which you cannot do with just the RGB information that you get from normal images. And that's very, very powerful today in terms of what applications can be actually built and operationalized for any business. So, and where does AI and big data come into the picture? I've been talking about space data. So one of the very key reasons why this type of data is becoming more relevant today for all the industries which never worked with satellite data before. So far, it has always been the defense, oil and gas, these kind of government agencies that has been using this data. But with AI and big data technologies, it is enabling many different organizations, from nonprofits to impact investment, development banks, insurance companies, mining companies, shipping companies, everyone to say, hey, what can I do with this in my business? Can I do it today? And the answer is yes. You can already start testing what you can do it with today, and a lot of the merit actually goes to big data technologies and AI. So with big data, why is it important? Because, like I said, we have hundreds of petabytes every day that we need to download. So even if you're working on one simple application, you are still dealing with a huge amount of data, and the ability to be able to process it and work with it is today possible with the cloud technologies, the big data technologies, the way to compute that large data sets in a more operational, industrialized manner is changing. It's changing this kind of work from research labs to the possibility that I can put it in business and operationalize it to a whole large scale. And in terms of AI, one of the key developments that has definitely changed or transformed computer vision is also transforming satellite imagery, what you can do with satellite imagery. If you look at satellite imagery data, you would think it's a pure computer vision problem. It's not entirely a computer vision problem. There's also a lot of depth of information in it. So it's a mix. But then all the developments we see with computer vision, even though they are built on top of RGB data, a lot of the fundamentals are also the reason behind progressing this technology, progressing the applications that we are able to build with these data sets. So it's the same fundamentals. For example, be the UNets. These are UNet, ResNet, these kind of standardized machine learning architectures have actually helped build many more satellite imagery applications. There is a lot of work to do on the back to be able to customize it and make it work, but it's already given a very good starting point to build applications that would otherwise not be possible at all. So, and also, there are a lot of technical difficulties working with different types of satellite data, and be it resolution or consistency between, can I use data from two different satellites and still do the same thing without making it look any different. So all of that is also possible because of the computer vision algorithms. And like super resolution, for example, we are able to use that to mix two different satellite data of completely different resolutions and then say, hey, I can alternate these kinds of data. I can use training data from one satellite to actually train data for another satellite image. So this really opens up a lot of possibilities. And same goes with like architectures like GAN, which have actually made building training data more possible, which is today, even now, one of the big bottlenecks for this industry as well, which is also the case in many other industries. Having training data is still really, really hard, especially when it's very important where you're taking that training data from and at what time was that training data taken at. So the time and location makes a huge difference with your training data and also limits how much training data you have. So having architectures like GAN can really accelerate how much amount of training data we have, and so the applications you can build with it. So I said a lot of things. So how does it make sense for any of your businesses? All these changes, all these developments, what does it mean for all the organizations and businesses? What it means is, so far, with all the effort, with all the hiring of experts, be it in Earth observation or machine learning, what you could do in a very small scale, in a very specific application, today you can scale it in terms of location, in terms of types of applications. So to give you a very good example, looking at in agriculture, looking at crop type classification is not new. Using satellite data to do that is not new. But then every time a model was built, it was such a close-knit mathematical model, agronomic model, that every time you need to build it for a new variety of crop, you start from scratch. Every time you need to do it for a new region, you start from scratch because, the corn in France does not look entirely exactly same for corn in Brazil. So you need to then improve your algorithm and build one for that region. So from there, today, because of all these progress we've made in AI, big data, and just the satellite accessibility, it's much faster to scale to say, okay, I have built something for corn in France. Can I now calibrate and expand this to corn everywhere in the world? And then I want to be able to do the same thing to detect soybean, detect sunflower, detect apple trees for the whole world. Yes, you can totally do that today. And when you have that in your lab, can I industrialize it in a way that I can immediately have this done every single day or every month or every season and have it downloaded as a report for me? I don't care about the process, I just get the report. Yes, you can totally do that today thanks to the AI, big data, the cloud improvements that we have made. So this is what it means. So now let's do something a little bit light and let's talk about a case study. So in this case study, the goal was to detect waste in the ocean. So usually floating in the ocean, not really on the beach sides. And this is a really good example of where satellite data can actually help. So in this use case, I want to see out there in the ocean, kilometers out of the shore, can I detect all the waste that floated there so that I can have some ships pick it up or clean? I can manage and create ways to clean that up. But today, if you want to do that, how will you capture that information in the first place? And even if you do, how will you have an application that can consistently help you see that in open ocean? You cannot send drones there. Definitely you can send airplanes, but how many times in a year will you send one? And so with satellite data, it's a really good space where satellite data shows what it can do and what it can help create just for as a use case. And why? And to talk go a little bit technical in terms of this use case. One of the reasons why satellite data is interesting, even though the resolution sometimes, most times, is really, really bad. So can I look at a plastic bottle with satellite data? So today, the best satellite data you can get is 30 centimeters. You can go down to 25 centimeter pixel level. So each pixel is like maybe this much, like maybe this much. But still, you can't see a plastic bottle. At least if you look at it with your own eyes, you won't be able to detect it's a plastic bottle. But with your algorithms, you're still able to identify that pixel to have a plastic bottle in it. And the reason for that is the data behind it is much, much richer than just the red, green, blue bandwidths you see in normal imagery. And what does that mean is every time when I look at something or when there's a light reflected by any material, it has a very specific spectral signature. So if my satellite image is able to capture more than RGB and go towards 10 different wavelengths of light, 13 different wavelengths of light, and I start looking at different, and I group the wavelengths it's reflecting back for different types of material, you will see more or less like the graph you see there. So each graph here is a completely different material, and the x-axis is the wavelength of light it's reflecting. So the wavelength of light it reflects is almost like a fingerprint. Not that different, but it is different for each material, and that's what is used in this study and in most satellite application you can use that to your advantage to actually build algorithms with it. So in this case, as you can see, the blue one is seawater, so it's quite flat over there. And the plastic one is the black one. So it's very clearly, you can see like there are 6, 7 different classes of material just on the sea surface. And well, training data is required for sure, but just being able to understand this without needing very, very complicated deep learning models, you can already have a very good start. So this is what this paper did in this case. So what they tried to do is exploit the fact that every material has its own very unique spectral signature and try to find simple machine learning algorithms and build a kind of an automation to detect how do I combine this knowledge of spectral signatures and put it like a scoring system to easily classify what is a different material at pixel level. So here I'm really talking classifying at pixel level. It's a bit different from the computer vision applications of classification we see, because in computer vision application, you have convolutional networks looking at series of pixels at any single time to be able to make that decision. But here you are really looking at a single pixel level. So that is why I said earlier that it is still this kind of technology benefits from computer vision, but it is still a bit different, and you still need to take a few different approaches. So in this case, it's not a computer vision application. So I'm at each pixel level. I'm trying to identify this, use the spectral signature, create a score, and say whether or not is it this material or that material. So I want to, at the end of the day, in this whole big image, I want to individually identify pixels that are plastic. So that is the first step you can take, because before you can start looking at any patterns, we need to know whether or not can I identify certain differences and be more accurate about like overall patterns of how this plastic might be floating, or what kind of patterns it might be forming. So a first step is definitely looking at pixel level data, and then try to improve the accuracy by other computer vision methods, by looking at surrounding pixels, by looking at the patterns of how these plastics are formed on the ocean. So in this case, one of the big challenge is lack of labeled data sets. You can always try to find interesting ways of doing that. So because if I'm trying to look at the spectral signature of plastic, I don't necessarily always need it from the middle of the ocean. I can try to have it in other garbage dump sites where I know there was plastic, and try to extract that from what that looks like from satellite spectral signature. And another problem was there are many different type of debris, right? It's not just not plastic. There are a lot of different materials that are possibly floating on the ocean. So we need to also have labeled data to be able to see that. So these are some of the basic basic machine learning problems with labeled data sets. And one good thing to know, in this case, the data used was a 10-meter resolution data. So at any point, at any single pixel, you are not looking at one single plastic bottle, except you're trying to look at, was there a bunch of plastic waste in that pixel? So in that 10-meter by 10-meter pixel. So that's a huge amount of space to look at. So even then, it was quite accurate, this kind of analysis. The output at the end was it is 6% accurate in terms of its classification. So it's a very good start, but I don't think it's anywhere close to industrializing, but it's a very good start to be able to start seeing where this kind of sediments are, locate them, and try to have locate them not just in this one part, but you can do that kind of geolocation all over the world, and you can see also how this is moving and where is it going to. So you can really track it as well. So if you can do that all over the world, you can imagine what are the different things you can do today. You can really create missions. You can see the need to actually create a mission in the first place. Do you or do you not need a mission to clean up the ocean is a question today. We just assume there is waste, but it's not so much, or there's a lot of waste. We really need to act. How do you know for sure? This is one way to do that. And that can also give you a means to validate that, yes, this is the amount of waste out there that we generate is floating in the ocean, that we really need to clean it up. And so there are a lot of technical challenges also with this. In this example, one of them is clouds, which is definitely a major factor in most kind of satellite data except radar. And in terms of image processing, making the training data ready, apart from everything you would normally do for any kind of computer vision computer vision data sets, the other things you need to do in this case is correct for clouds, cloud shadows. If there is snow anywhere, you need to reject those. And sometimes you will also have to look at corrections for geometrical corrections or radiometric corrections. These are very specific to the domain, and that is where I think there is a little bit of gap between a computer vision scientist today. Can they or can they not directly start working on satellite data? There is a small gap, and that needs to be closed before computer vision data scientists can look at this data like any other data. So so far that's the use case. So coming to, that's one use case, but since the last few years, with more and more satellites going to space and more people are able to access this data much more easily, they're asking themselves, what can I do with this data? And there are so many applications that are coming up, not just because of access of data, but because of progress we have made in machine learning, AI, and big data. So now more applications are possible, which were actually not possible without these advancements. So for example, monitoring tracks on the railroad is a real use case that can help save a lot of money for the train companies like SNCF, for example, where they can, especially in remote areas where they don't have actual people visiting the tracks and inspecting the tracks regularly, you can use this technology to detect if there's a tree that fell, or that something is blocking the tracks, so you can remove it in time so that the operations are not stopped. So this is one good example. But for this, what do you need? You need data frequent enough that you can actually check this. If you get one every 5-6 days, then, my track could be blocked for 5-6 days. But today it's possible to actually have data, a satellite image every day, very easily, and more companies are actually pushing it to have time delay of almost 90 minutes, which is crazy, to be fair. And this kind of use cases are only possible because of that capability. And another one is, you might have heard quite a bit about carbon credits. So how can you, in agriculture and forestry, how can you validate and monitor how much carbon credits have actually been generated? So that's one other space where satellite data and AI can make a huge difference. So to give you an example today, to validate carbon credits in agriculture, you need to know what is the amount of organic carbon that is in the soil. And you need to track back 5 years of that field, what were the different practices that took place on the field. For example, did they do tilling? Did they change the crops? Did they have like intermediary crop so that their soil is always staying rich? So they need to track these. The only way today they are able to do is they have farmers give them written notes of what they've done in the 5 years, which is definitely not the best way. And another place where satellite data helps is today to validate the carbon credits. They need to go take a sample in the soil for every field there's a claim of carbon credit and validate that, which is quite insane, and which is today one of the big roadblocks in making like carbon credits for agriculture actually profitable for businesses in the value chain. So with satellite data, you can, one, validate what has been happening on the fields for the last 5 years, but at the same time try to automate, try to reduce the need for in-person soil samples. So that can already change what is the value, at what cost can you validate these carbon credits, and how much value are you able to bring back to the farmer and the one that is buying this carbon credit. So that's another pretty interesting use case. And there are more use cases, like, for example, being able to monitor your sites. I think with COVID, one of the things I've seen is people are looking ways to monitor and keep eyes on what is happening in person about the infrastructure from home. How can you do that? One way is, for sure, you can buy drones or hire drones, but it is still hard to do it in a more consistent and operationalized way if you have hundreds and thousands of assets. So definitely satellite data is helping there, and the improvement in radar technology from satellites, the very high resolution radar technology, is actually making it possible for you to monitor your assets, the properties, what kind of construction is happening, how much has it happened, and what buildings are there, with very, very precise, very, very precise way. To be fair, if one easy, simple way to map all of Paris, to create like a 3D digital map of Paris, would be with SAR, very high resolution SAR data, and you can do that. And an alternate to this so far was done by New York, where I think they took many months of time to actually survey every building that existed in the city and create a real 3D model, which I think by now is outdated. But to do that in real time, to be up to date, it's really only possible with SAR data at the operational scale. And so we spoke a lot. Let's talk about what is it that you can do today with this technology. How can you get started? How can you identify what you can do, but also start testing these solutions? Well, first step is always the same case with any kind of new technology. Be curious. Try to think of use cases. You are the expert in your domain. You know your business more than anyone does. I'm like on my company, we know satellites, but we don't know your business. We don't know insurance. We don't know agriculture as well as you do. So it is always to it has to start from you to think, okay, this is what I need to do. Can satellite help me do this? Yes, or can I look into this? So it's always, that's where I think there's a huge gap today, where there is a huge knowledge gap to understand what is possible, what can be done, and that needs to be closed. For sure, we as satellite imagery companies, we will make the effort, but a lot of the initiative also comes from the companies themselves that ask, the teams in the companies that ask, I have this problem I need to solve. I have this use case I know will either help me make more revenue or save a lot of operating costs. So is it possible to solve this problem using satellite data? And today, I think you'll find for most of your use cases, you will find something similar in your that somebody else has done. Even at least in research, you will find it. The second step is where we come in. Once you identify that you have a use case and you want to quickly try whether or not this is possible, because that's where, honestly, most of the industry is, most of the use cases are really new, and there is no yes or a no to whether this is possible or not unless you try it. And that's where we come in. We are, with our platform, your data scientist, you don't need to hire any kind of new expert, new Earth observation expert, can quickly test and see, can you or can you not solve this problem with satellite data. So that's where we come in. So anytime you are through to step 2, reach out to us. And step 3 is once you find a solution that works for you. So with our platform, you can, and honestly, there are a few more platforms that are trying to make satellite imagery more accessible, make it easy for companies and teams to build applications with satellite data in a more faster and more affordable ways. And once you can use them to test your use cases, validate them, do prototypes, trials, pilots. And when you're through that stage, when you see, okay, this is working for my use cases, is really good, now I need to industrialize it and make it available, make it like normal operations every single day. We still can help in that process too, because putting a satellite data in production is its own task, I can tell you that. So we can definitely help, but that's definitely your next final step where you see the benefit, now you want to benefit from it at a large scale, operationalize it, industrialize it. So that, and of course, once you industrialize it, you can start reaping the benefits from it, hopefully. That's my presentation. I hope it wasn't too boring, and I am open to all your questions.
Nous allons passer, merci, cette très belle présentation. Nous allons passer donc aux questions-réponses, au jeu des questions-réponses. Est-ce qu'il y a des questions qui viennent Non. It's yes, we have a first question here. I will just before beginning the question, it's I do a study on this market, and it's incredible. We don't imagine what we can do with spatial images, and it's I'm thinking it's an extraordinary future for you and for companies using those images.
Yeah, absolutely. I think there are so many use cases that can help almost most industry segments today in so many different factors. Mm-hmm. It's really open to our imagination at this point, and for teams to start trying, get dirty with the data.
Mm-hmm. Just to explain, a big city in France is looking for a swimming pool to put tax on swimming pools, and with the images, spatial images, I can do that, and you will see if you have a swimming pool, be quite prudent, you will see tax arriving. Si vous pouviez vous présenter avant de poser votre question, s'il vous plaît.
Christopher Arnold. I work for Bouygues Telecom, the telco operator. One of the use cases we might have is the positioning of antennas for 5G, 4G. Sometimes it happens we don't really know what happens on the field, whether the antenna is well positioned, or if we have two antennas side by side, which one will be the most fitted to, I don't know, to catch the more clients in this area instead of this one. So do you have any use case related to any telco field like this, like placing specific strategic, technical, I don't know,
So it's a really good question. So we don't have we haven't worked on exact same problem, but I can connect it to a few other things that we have seen. One is looking at the supply chain. For example, let's just take, for example, Amazon kind of a company. They need to know where to place their large distribution centers and where to place like the smaller ones that immediately like for ready for delivery, like smaller ones, and where to put the self-service ones. So that's the same kind of optimization they need to do. And for that, what kind of information would they need? This is also something you need to think about. What do you need to know to be able to make that decision? And can you get that from some of it you can get from satellite data. For example, in this use case, I need to know how is the population distributed. So I would look at high-rise buildings, smaller buildings. Of course, I can already use the addresses that I already know where the packages are coming from. But you can already look, like if you're looking also ahead, you can look at distribution of your population and also where do you have space to actually put this. So you can also look at building sizes, where you can place it. So these kind of things you can extract from satellite data. And same thing in your use case. It's a mix of geospatial analysis where you're saying you have your business constraints. Say, if I put my antenna here, this is the range I have. And you need to have that kind of a model where you know that if I move, like this is my range. So those are your constraints. So you know them. So that's geospatial, layer of geospatial information you have. So between the two, if I remove one, you can just use your geospatial simulation to really check what zones are covered and what zones are not covered. It's a simple application. Say, okay, each point of my antenna covers this much space, and you can very easily see blind spots there. Something very similar happens to satellite constellations. When they try to send constellations, they try to do the same simulation and try to see what are the blind spots. And another point for you, where to place your antenna, might also have other constraints, be it location constraints, terrain constraints, and you can directly get information about it from satellite data. I hope this answers your question. Yeah.
We have a question online. Can you give some more examples of use cases? Well, it's the first, but do you need to connect to weather models, and which ones? I see the need to remove clouds, for example.
What was the first question?
The first question was on other use cases.
Yes, for sure. We have many different use cases in most industries. So be it for, one good example was distribution, supply chain, how to optimize it in terms of distribution centers. But same thing goes for data centers. How do you optimize that? We look at carbon credits as different ways to capture it. Emissions, also, again, coming back to sustainable development and carbon credits, we can very granular levels, we can locate where is this methane emission coming from, where is this NOx emissions coming from. So yes, absolutely, there are many different use cases. And for your second question...
The second question was, do you need to connect to weather models, and which ones? I see a need to remove clouds, for example.
Yeah, to remove clouds at this point, we don't need to connect to any other data source. It's actually a pure machine learning classification, segmentation problem, which is being dealt with, well, two ways. One, looking at pixel level and try to separate it based on the spectral signatures, and looking at the spectral signatures of clouds as an anomaly, and you try to do that. It's not perfect, you know. Clouds are not always the same thickness. They can be really, really thin layer. That'll make a difference. And you are also worried about the shadow of the clouds, which will look like a normal image if you don't have the cloud in the picture, but it's actually giving you wrong information at the end. So it's more of a image segmentation problem. We don't really need any other data source.
OK. D'autres questions?
Yeah.
Ah, nous avons une question plus loin.
Yeah, my name is Pranay De from Teradata, Principal Data Scientist. I can imagine that false positives in your business would be very expensive. Let's say you have detected, let's say, floating bottles or trees on the track. But actually, before sending the team there, do you verify it? Because sending the people but in fact, if the problem is not there, could be very expensive. So I'm just kind of thinking, how do you manage false positives?
I think it's a similar challenge that every AI company tries to face and tries to find ways to check. With satellite data, an additional challenge is, even the same apple trees will not look the same in two different countries. The soil looks different colors. So in itself adds additional possibilities of that kind of false classification happening. So what we try to do right now in a way to provide that scalability and reliability at local level. So every time we work with most companies today, most of the time their goal is not global. Most of the time they have a local requirement. So in your example, say it's trees or forests you're looking at, it's always local. Either you're looking at France level or even less, a small part of France, that's what you're looking at. So what we try to do before we make our solution available for them is try to capture a certain amount of data locally for that region they care about and try to test it with our satellite data and provide them what are the results. And if possible, if we have the data and if the customer can do this, we try to calibrate it and make it more adapted, have a version of our generic model more adapted to that region or that kind of crop. So that I see there is still a need to do that. One model will not, is right now, because of data needs and because of all the differences in geography, it's still very hard to have one model that will work for everywhere.
What is the future of your technology? What are you waiting?
What are we waiting? We are waiting for you all to realize that satellite imagery can be used in your company for your businesses, and we're really waiting for you to get started on using it. Really, that's the only thing stopping us.
Okay, but on the technological part, for example, you explain we see constellations of more satellites and more images, but I don't know if all of those images are very useful. And what are you waiting on this part?
Yeah, in terms of technology, things are changing fast, but like one example I gave you, the train tracks problem. So that problem, yes, I can have a model to detect if the tree falls, but that can become an application usable by the company only if I can do it at a specific repeat interval. So if I can't see it at least every single day, I guess it's not giving me enough benefit. I can have one person go see that location every week and that's fine, it's not changing. But if I'm able to provide something much better than what is already happening, like if I'm able to do that revisit times, only then that is possible. For that, what is stopping us today is to have, in this very specific use case, being able to afford and have one image every single day for the same place. So right now it's a bit of cost. Yes, we can do very high resolution in that spot, but it's expensive today, so that it is still, it makes a real business case. So that's one of the challenges.
Okay, thank you. And we understand that you are waiting for us to come with usages, future usages, and it's important, I imagine. Okay, thank you, Jyotsna.
Yeah.
And, écoutez, on va continuer cette conférence. Merci, vous pouvez l'applaudir. Hein?
Thank you very much.
Déjà, l'exercice n'est pas simple. Et de plus, je peux vous dire que ce que vous avez vu n'est que le prémisse de ce qui va arriver bientôt et dans le futur en termes d'exploitation de l'imagerie spatiale. Thank you.
Thank you, and feel free to reach out to me. We're a small startup, so we'll respond really, really fast. So have a good day. Bye.